In this video, we will learn about differentiating implicit functions written in the context of exponential functions. Let's revise the basics of differentiation of exponential functions. If y equals to e raised to power of ax plus b, dy by dx, exponential function remains as it is, and derivative of power comes down and multiplies. That is the basic technique of differentiation of exponential functions. Let's look at the first question. We have x e power y plus 2y equals to 1. It's an implicit equation, and we are interested in finding expression for dy by dx in terms of x and y. The rule is differentiate both sides with respect to x. So WRT stands for with respect to an x. So d by dx of x e power y plus 2y is equals to d by dx of 1. Now over here, x, e, y are two functions of x. So therefore, product rule is applicable. Derivative of uv, that is u multiplying with v prime is the first derivative, and v multiplying with u prime. So when we solve this expression, in terms of differentiation, we will write x multiplying with d by dx of e power y. Similarly, e power y multiplying with d by dx of x. So let's draw a bracket over here also. And let's put a big bracket over here. This is for this particular expression. Now focus on this 2y. So therefore plus sign and derivative of 2y with respect to x. And last but not the least, derivative of 1 is 0. So now let's simplify it further. X multiplying with e raised to power of y dy by dx. Ey multiplying with 1, derivative of x is 1. D by dx of 2y, that is 2 multiplying with dy by dx equals to 0. Gather all the terms with dy by dx on one side. So what do we have over here? We have dy by dx, and this is xey, and this is 2 dy by dx, and this is equals to 0 minus e raised to power of y. So now we can take dy by dx common, and what are we left with? We are left with xey plus 2 is equals to minus e raised to power of y. Make dy by dx the subject of the equation. Minus e raised to power of y is in the numerator. Xey plus 2, that goes down in the denominator. This is the expression for the gradient function. Let's move to the other question. The question is e raised to power of x plus y, and this is 2x, and we are interested in finding expression for dy by dx in terms of x and y. We will start by differentiating both sides with respect to x. What's on the left hand side? E raised to power of x plus y. What's on the right hand side? 2x. Now this is the power of ex plus y. Therefore, we will take the derivative down, derivative of x plus derivative of y. This goes down. E raised to power of x plus y remains as it is. And derivative of 2x is simply 2. So derivative of x with respect to x is 1. Derivative of y with respect to x is dy by dx. and this is multiplying with e raised to power of x plus y, that is equaling 2. Scrolling up, I'm left with 1 plus dy by dx is 2 divided by e raised to power of x plus y, and making dy by dx the subject, that is 2 over e raised to power of x plus y minus 1. This is the final expression for the gradient function dy by dx in terms of x and y. Let's look at the third question. We have e raised to power of x multiplying with y, x multiplying with e raised to power of y. And we are interested again in finding expression of dy by dx in terms of x and y. Differentiate both sides with respect to x. So we have e raised to power of x multiplying by y on the left and x multiplying with e raised to power of y on the right. Now, this is an application of product rule. This is also an application of product rule. This is u, this is v, this is u, this is v. Therefore, e raised to power of x multiplying with d by dx of y and y multiplying with d by dx of e raised to power of x. That is the working. And then on the right hand side, we have x multiplying with d by dx of e raised to power of y. Similarly, e raised to power of y multiplying with d by dx of x. Now let me annotate it. This is u, this is v prime, this is v, this is u prime, this is u, this is v prime, this is v, this is u prime. So now let's simplify it further. We have e raised to power of x. This simplifies to dy by dx. Y remains as it is. Derivative of e power x is e power x. X as it is. Derivative of this expression is e raised to power of y, dy by dx. And e raised to power of y as it is. Derivative of x with respect to x is simply 1. So now there is this term with dy by dx. There is this term with dy by dx that has to be transferred on the left. So therefore, ex dy by dx, and transfer this term to the left, negative sign, x ey dy by dx. And what else do we have? Equal sign, e raised to power of y as it is. And this term will be transferred to the right, that is y e raised to power of x. Now, let's take dy by dx common. So we have dy by dx. What's left on the inside? E raised to power of x minus x e raised to power of y. What's on the right hand side? E raised to power of y minus y e raised to power of x. Therefore, dy by dx is made the subject, that is e raised to power of y minus y e raised to power of x. That is the numerator, divided by e raised to power of x minus x e raised to power of y. This is the simplified version of the gradient function. Let's look at question number 4. We have the equation of a curve is this: y e minus 3x minus 3x and equaling y square. And the question is being asked about equation of tangent to the curve at the origin. This is the equation of the curve. So differentiate both sides with respect to x to find the gradient function. Again, product rule is applicable over here. So therefore, y d by dx of e raised to power of negative 3x plus e raised to power of negative 3x d by dx of y. This much is about the product rule uv prime and vu prime. So this is product rule. And now there is a negative sign and we are differentiating 3x with respect to x. On the right hand side, we are differentiating y square with respect to x. So we have y here. Differentiating this is minus 3e raised to power of negative 3x. E raised to power of negative 3x as it is. Derivative of y with respect to x is dy by dx. And then differentiating 3x with respect to x is 3. Differentiating y square with respect to dx is 2y dy by dx. Let's make dy by dx the subject of the equation. So therefore, e raised to power of minus 3x dy by dx, and then bring this term to the left, minus 2y dy by dx, and we will take this particular term to the right hand side, that is positive 3y e raised to power of negative 3x. It had a negative sign over here, taken to the other side becomes positive. This negative 3 taken to the other side becomes positive. Now let's take dy by dx common. So dy by dx, e raised to power of minus 3x minus 2y is equals to 3 common, and y e minus 3x plus 1. And now we are making dy by dx the subject, that is 3 y e minus 3x plus 1 divided by e raised to power of minus 3x minus 2y. Now let's scroll up and look at the question. The question is asking, find equation of tangent to the curve at the origin. Origin means that the point is 0, 0. So we know that x is 0, y is 0, and now we are interested in finding equation of tangent. The gradient is the same thing as dy by dx. So all you have to do is to plug in x is equals to 0, y is equals to 0. So therefore dy by dx 3, 0 e raised to power of 0 plus 1, and divided by e raised to power of 0 minus 2 multiplying with 0. So this is 0, this is 1, this is 3. So there is a 3 at the top, the numerator. And this is e raised to power of 0 is 1. This becomes a 0. So therefore dy by dx is coming out to be 3. So gradient is 3. Last but not the least, y minus y1 is equals to mx minus x1. Using this format to find equation of straight line, which in this case is a tangent. Y minus 0 is equals to 3x minus 0. Therefore, we are left with y is equals to 3x, which is the equation of the tangent to the curve at the origin. So what have we learned in this particular video? We have used the technique of differentiation of implicit function to differentiate equations which are related with exponential function, and using the gradient function to find equation of tangent when needed.